Okay, let's talk about glucagon. So that's made by the alpha cells of the pancreas. Ah, alpha, the gluca's gone. And it promotes glycogenolysis, gluconeogenesis, lipolysis, and ketogenesis. Elevates the blood sugars to maintain homeostasis when the bloodstream glucose levels fall super low, like in fasted states, for instance. And the regulation is secreted in response to hypoglycemia, and it's inhibited by insulin, amylin, somatostatin, and hyperglycemia. Okay, so let's talk about a practice question here. We have like a skipped meal and then somebody gave themselves an insulin shot. Now they have hypoglycemia. How do you reverse this? Well, glucagon would reverse this by activating the liver to release that glucose fast. Okay, so some key features here: insulin injection without food, passing out, glucagon injection, recovery, and there we go. Voila, it happens via CAMP and then PKA, which then activates that glycogen phosphorylase. So a practice question: diabetic patient skips a meal, insulin, recovers rapidly with glucagon. Which organ's responsible? That would be the liver. Glucagon directly activates the hepatic glucose output via glycogenolysis and gluconeogenesis. Let's make some glucose. We need some glucose. The alpha cells of the pancreas. Trap answers: the adrenal gland. These guys release epinephrine, supporting the long-term glucose metabolism mobilization. Epinephrine helps with the fat breakdown. And then the skeletal muscle, that's wrong. Glycogen is stored here, but the muscle can't export the glucose because there's no glucose 6-phosphatase. And so the muscle uses the glucose for itself, not to raise the blood pressure. And so glucagon has no effect on the skeletal muscles. Renal cortex. This contributes to the gluconeogenesis during the prolonged fasted state, and it's more influenced by epinephrine, not glucagon. Pancreas. This makes glucagon, but it's not where it acts. Glucagon stimulates insulin released paradoxically, but that's just a minor effect. So it's not responsible for the blood sugar rise. Adipose tissue. So epinephrine acts here in the adipose tissue to release the free fatty acids for energy. That's epinephrine though. Glucagon does not affect this adipose tissue, just the epinephrine acts here. In the small intestine, glucose is absorbed here, but it's not where it's produced. So hopefully this is helpful. Just a little table if you want to check that out. And like and subscribe for more information.